Seth, and I hope you guys are doing well. Thanks for coming and watching this little presentation. It's a little bit different now. We got some new norms in the world that hopefully don't last too much longer. I'm used to doing this live. Obviously, you guys are used to attending live. But I want to talk about my company, Simply Coding. I'm one of the founding owners of it. We got a great group of guys, and we've been running about 7 years. Now, originally, we were working with schools, and we still do. Charter schools, kind of the traditional schools. We sold on Amazon. We still sell on Amazon. And then we noticed these pockets of great people buying up our courses, and it was this homeschool community. So about 2 years ago, we kind of turned our attention and said, let's go to these conventions. And we went and we spoke, and I just met some incredible people. I love it there. We love working with co-ops. I'm very proud, very pleased with what you guys accomplished with your children. So congratulations to you. Now, one thing that we'd like to talk about is from gamers to coders. That's a heavy topic. Gamers, especially in a community that has so much focus and interest in their own children, and how much screen time, all that sort of stuff. And we know there's no one right way solution, but a lot of us who are coders and who have programmed also have some experience in the gaming world. And so I thought this is kind of a fun topic, from gamers to coders, with the idea behind it is don't consume it, create it. Let's just not consume it. Let's also understand it. Let's know how it gets from an idea to actual in front of people. And there's some great skills involved with that. We know that our kids, the kids in the world today, are going to be confronted with computers. Technology is a big industry. Cybersecurity, programming, what we're talking about here, there's just a ton of opportunity, a lot of paths you can take. If you understand coding, for sure, but how a computer works, how it thinks, how it does what you want it to do, even, and I mean, it makes very accurate mistakes. It does exactly what you want it to do. And if you understand those things, then opportunities are out there. So we want to talk about not consuming it, but creating it, from gamers to coders. So I have this little slide here, and it's going to work. There we go. So first, we always ask, are there any gamers among us? We usually have everyone stand up. Obviously, I have no idea, and I doubt anyone would stand up. And we're going to show you a picture of a game, and if you have not played that game, you take a seat. So that's how we do it in the auditorium. In the virtual world, it's an honor system. Scouts honor type stuff. So here we go. This is the first game. I believe everybody has played this. Pac-Man, I don't know what it did for your life other than anxiety, but it was a game that was out there. Donkey Kong, this is the first game those barrels are very tricky to jump over those barrels. Come on, computer, let's go. Mario, we've all played Mario. Mario 1, 2, 3, 7, 8, 9. I don't know how far they went, but we've all played Mario. This one is called Sonic. So if you had a Sega Genesis, this is what you were looking at. The rival of Mario. Tetris, oh man, my brother, I could not wait for him to go off to college. And so I could get his Game Boy. He had Tetris on there. He wrote his high score down on this table, and I tried to beat it about 3 times, and then I gave up. All right, Mario Kart. This is the old one on the Super Nintendo. Everyone's probably used to the 64 where you could play 4 versus 4. Mario Kart, wonderful game. This was the hardest game I ever played in my life. It took many of my hours away. Vividly remember different levels, trying to pass it. Some of my buddies tried to rebuild these castles in Minecraft. Don't know how successful they were. That game was fun. Ninja Turtles. This one was the quarter eater. You would stick your quarters in, bam, 4 people all playing Ninja Turtles. That was fun. This game looks like it's from the same era, in the 70s and 80s. This we know as Minecraft, where my son tells me all about redstone, and that's a fascinating thing we'll come back to. But the middle school, elementary school kids, they love Minecraft, and they still do. Street Fighter 2, this was a good game. Now we're getting into my favorite game. Many of you guys may not recognize this game. This is Warcraft 2, a real-time strategy where you're building a city the same time they are and you're going against each other. This game is fascinating to read the backstory of Blizzard. But this game is interesting because it came with a map editor. And its successor, StarCraft, came with a very sophisticated map editor. And that's actually where I started getting into coding, is trying to understand how this map editor worked with if statements and conditions. So that was kind of an interesting thing. Contra, somehow you could get 30 lives, up, up, down, down, left, right, select, start, A, Bs are in there too. Get yourself 30 lives, that was a fun game. So those are just some games to look back on to say, okay, I played some games too. Even though I wasn't a hardcore gamer, I don't have a lot of nights where I was up playing games past midnight. But it wasn't part of my life. It kind of built up, and I didn't understand how much logic I learned from gaming until I went into programming, until I started programming and saying, hey, I know how to do this. That's the exact same thing I did in StarCraft building the map editor. It's an if statement, and this is the else statement, and if this isn't true, then this has to be true. And you start to see that logic. And games, the thing I like about games when we're teaching students how to code is you can only take them so far. We can do all these lessons, and they can build all these resources, and they can have fun doing it, but eventually you have to say, time to build your own project. It's time for you to come up with an idea, and let's code it out. And that's where you're going to find out if you're a coder or not, because now you're coming up with not only your own problems, but you got to come up with your own solutions. And you may have seen things similar, but you got to twist it around, and it's got to adapt to your specific need, your specific situation. What's fun about programming is it's not math. It's not how do you get an addition problem to equal 4, where you can go 2 plus 2 or 3 plus 1, that's it. In coding, there are multiple ways to a solution, some more clever than others, some more efficient than others, but we don't care about that. There are lots of ways to get to a solution, and that's what makes coding fun, is your solution is plausible. There is a way to do it. So when we're talking from gamers to coders, we have to ask these kids, it's time for you to come up with a project. When we're talking about games, the floodgates open. We don't have this English teacher type thing where they say, okay, now you got to write your own paper on a subject you enjoy, and they're sitting there with writer's block. I don't know what to write about. We want to get the kids programming. Games allow us to not have to cross that bridge of, oh, I've never thought of what type of game I'd like. I was talking about my son playing Minecraft and Redstone. He comes up to me and he unloads his Minecraft stories on me. And luckily I understand a little bit of it so I can talk to him, but you can just see that excitement of, I did this, and if I wonder if I did this, if it would still work, and I built this structure, and that's neat. And we want to take that same enthusiasm and have them code. And when we're using games as the medium, they have ideas. They have things they want to edit. They have things they want to customize. And it's really similar. You're building a game, you go and get a job later on, or you're in school and they want you to do this to a website. That logic translates. It translates very, very well. So I worked for this company. It looks like I worked for Bluesky. They said it was Blue Sky, so I'm going to take their word for it. That's what we call it. We call it Blue Sky. And I was talking to to one of the bosses there. So we had a group of 6 programmers. This is before I knew how to program. I was a project manager, and we were working on a project. So I was working really close with the programmer. Great guy, Tyler, still my very good friend. We've had a lot of great work together. So he's this programmer, and he's sharp. I mean, he was the kid who went to the library, read programming books, taught himself, went to college, did phenomenal. So we're programming this project, and I would start to ask him, like, which programmers do you like working here? I'm starting to get the idea how programming works, seeing the logic. I didn't know how to write code, but I could read it a little bit. And he points to this kid. He's like, that kid right there is my favorite programmer. And so I asked him his background. He's like, he went to a semester of college, but he built all these little programming projects, and he finally built this system that would manage email lists and list management, allow you to split it and merge it. Unsubscribe. So we built this list management system just for fun because he wanted to do stuff with data. And Blue Sky bought it and hired him to run it. And here's this kid who has 1 semester of college under his belt, making more than these other kids who were still making great money, who were graduated from college. I don't want to put college down. What I want to say, and this kid could have gone to college and got through it. He'd still be as talented, but he was what they call a tinkerer. And when I talked to him, he said, when we hire people, we want tinkerers. We want to find out what's in your portfolio. What have you built? Where's your ideas? Another great example, my brother. I started a company before Simply Coding where we were working with programmers, hiring programmers. I hired my brother to help me run it, and I loved working with him. I wish I still was, but he decided he wanted to go get a programming job, and he built his project that he wanted to do was called the Twitter API. He wanted to learn API. So he would take Donald Trump's tweets and he would translate them using Google Translate through code, through the API. He would tie into Twitter. He would tie into Google Translate. he would pull down Donald Trump's tweet, translate it into Russian, and then take that translation, translate it back into English, and then post it. It was this Russian Trump bot. And it would come out kind of funny, you know, once you translate it twice from Russian back to English. I don't think it made any more or less sense. But that was his project, and he went and he showed that to a company. I know how to do APIs. Look at this project I did, and they were blown away. They said, this is perfect. This is what you're going to have to do with our company. You're going to have to pull down data, manipulate it, and push it somewhere else. And so that was his project that got him hired. And he did some other things, but that was one that he liked. In the interview, it came up and they talked about it. But that's how interviews go in technology. You know, what have you done? What have you messed around with? What have you tinkered with? Tinkering is very important. While we're doing our courses and we're working with these great kids, and we love the middle school age group, we love the high school age group, but we like to see them mess around with our lessons. It does a lot of great things for them. So what is tinkering? So a tinkerer edits and rearranges the code after doing the lessons. I'm talking specifically what I see. You know, I run after school programs, summer camps, we have our online courses, we work with independent schools, charter schools, we have our homeschool groups. And so what are we trying to get these kids to do? We want them to not fear mistakes. We want them to not fear messing up. We want them to edit, rearrange. You learn this from the lesson. What can you change? And it starts off by, let's changing the size, let's change the speed, not necessarily adding new code or taking away new code or coming up solving these problems, but just start to edit, see what it does. And we'll talk about the computer languages that we use that kind of give way to this type of thinking. So we want them to be a tinkerer who edits and rearranges the codes from the lesson. The next step of that is we want you to come up with your own ideas and implement it into their projects. So we're going to have them build a project. They're going to build like the Pong game. They're going to build a little Mario game. They're going to build this fun little fish game. We want you to take that existing code and now just add to it a little bit. What if we put an explosion here when these two things collided? What if we had the image change after this happened? What if we made a power-up into the game? So taking existing code and just building onto it a little bit. That's a great sign of a tinkerer. And then the last thing, and this is our job, this is what I put on our shoulders, is we need you to now plan out solutions to solve their questions. We do this through, you're going to build a custom game, start to finish. Now you've gone through the lessons, you have these resources, but now it's time to plan it out. Plan it out on paper, plan it out in your mind. What are the relationships with this? And so that's where we want to get them. And they're going to recognize these things in their gaming. They're going to recognize it as they played Fortnite or Minecraft. They'll come up with ideas and they'll say, okay, I want this interaction to happen when this event occurs. And we want to break that down into computer logic so they can start thinking abstract. I love coding because of its abstract nature. I don't hone in on the specifics. I just think, okay, I want one thing to collide with another thing and it produces this outcome. And that's how code's written. And when you can start thinking like that, then you can start putting lots of different specific situations into that scenario. So why do we do this? One, kids have fantastic creativity. They have fantastic curiosity. We want to feed that. When they're editing and rearranging their code, that's when the curiosity is starting to build. That's when they're getting engaged with the code and they can start to understand how these couple lines of code really affect the game. And that's valuable in the business world. So we want to build their curiosity and engagement. That's why we gear these editing and rearranging parts. We want to see their confidence grow. So I work with these colleges and they get all these freshmen coming in as saying, I want to be a game designer, I want to be a computer programmer, I want to be in IT, I want to be cybersecurity. And their first exposure is in college as a freshman. And so I talk with these deans of the computer science departments and they tell me, this isn't across the board, but a lot of the colleges I work with, 50% of their freshmen drop out of the computer science major after their freshman year. Number one, they said, we also have 50% who have never done any code. Now, it's not the same group, but about half of the kids have never done any code before. That's an expensive experiment to try and code at that age. And it's not necessarily they just haven't done it, and it seems like a cool idea, so they come in as a freshman and they want to code. Half of them end up dropping out, and they just don't understand the learning curve. They don't understand what it takes, not to mention your freshman year of college can have all sorts of stress. And if that's an area that requires some learning curve, a little bit more focus, sometimes it's easier just to go in a different direction. But computers are great. Kids can understand coding at this age, at middle school, but some of them don't like it, and it's not a bad idea to find out if they don't like it at this age, or at least they know what it is. Now, as a business owner, I'm not coding as much, and so I don't have to know all the ins and outs. I'm not listening to the podcast all the time anymore, but being able to talk to a programmer who I've given a project goes miles in my business, where I understand what they're saying, I understand their timelines, I can now kind of speak their language, and I understand what they're talking about and why something's going to take as long as they say it is. And so maybe they're not going to be a coder, but number one, knowing what it is at a younger age so they can make that decision as they get older. And number two, they could go so far into it where they now understand it, and now it becomes an asset as they are a project manager working with coders down the road. So by doing these lessons and by coming up with your ideas and implement it, we want to build their confidence. We want them to feel comfortable. When you look at code, it is uncomfortable. Your first time looking at JavaScript, I was like, very uncomfortable. Especially if you're looking at Perl, an old language. It's just slashes and semicolons and parentheses, brackets all over the place. It's an uncomfortable area. There's a learning curve. So we want to build their confidence. We want them to get used to seeing brackets. And that's why in our lessons they code from blank template. They're going to have the real environment on their computer. They save all their stuff to their computer, and they're going to learn how to code. Now we want them to plan out, not just plan out. They're writing these out. They're really drafting a storyboard before they start coding when we actually get to their final project of building a game, for example, coding the game. So that's now going to show their understanding of computer logic. Everyone's heard the adage, you don't really learn something until you teach it. And that is true. As soon as you start to actually having to do something on your own and explain it, even if it's explaining to yourself. I know a lot of people who read out loud, so they're like, I can understand it a lot better. When you're explaining something even to yourself, it allows you to dive deeper. It allows you to ask questions that maybe you're uncomfortable asking a teacher. So this is what a tinkerer is. That big long spiel, I didn't plan on spending this long, but I got going. I don't always get going. I'm usually pretty short. But this is what we're after. We want them engaged. We want them editing, rearranging. Do not fear mistakes. We have live chat support. We can put it back if it comes to that. Don't fear mistakes. Let's mess around. Let's ruin it. See if we can put it back together. That's a tinkerer. So, spend all this time talking about tinkering. Let's tinker. Let's stop talking about it and doing it. So I am going to pull up some code. Now, usually in the crowd, I have some kids, and I love having kids in there because that's who I really want to get through to. And I show them a game, okay? And the way I show them this game is I've labeled it Secret Game. And I'm going to open it with a text editor so you can see the code. So this is, I'll just leave that there. Okay, so this is JavaScript. It's not terrible. JavaScript isn't terrible. You can look at JavaScript. Now there's things going on here, but if we really broke it down, you could see what was happening and you'd understand it. So what game is this? As I scroll through this code, are you thinking to yourself, hey, I think I know what this is. We got a ball, we got paddle 1, we got paddle 2. I know you're already screaming at me. It's Pong! We can move, when we hit the left key, paddle 1 goes left. Oh, we turn this into 2-player. That's what happened here. When you hit the A key, paddle 2 goes left. I'm gonna rearrange this because we're not there yet. This looks like I didn't delete it from the last presentation I did. Okay, so let's prove that this game is Pong. So let me open it in the browser. That code creates this game. Now the paddles move in unison. We have this ball, it's keeping score. Pretty cool, huh? I think it's pretty boring. So we have a boring game. So at this point, I open it up to the audience and I say, give me ideas. Let's tinker with this code. What would make this better? And this part's really fun because we get to code right in front of their eyes and I make mistakes and they yell at me, and you can see that, hey, coding and talking at the same time is tricky. That's why when you're a coder, they hide in their room, so no distractions. But I take ideas from the audience, and looks like last time we wanted independent paddles, different colors, a game over, function angles. I have no idea what that meant at that time. Explodes, faster ball. So these were all ideas from the crowd. The kids, I like to call them the kids, they're throwing out these ideas. Multiple balls. So then we'll take one. Okay, let's take multiple balls. We want multiple balls in the game. So you have to start breaking it down, and you have to ask a couple questions. When? How? Where? The questions that you usually ask your kids when they're about to leave the house. When are you leaving? Where are you going? How are you going to get there? Same thing in coding. We're asking that exact same thing. Okay, so we have this ball. When do we want it to happen? Let's say we want it to happen every second. Okay, how do we want to do that? Well, there's a timer in coding called a set interval function. That's not even how you do it. See, I already made my first mistake. Set interval function. And a set interval function, math is important in coding. They get to do their math. I typed in 1,000. This is milliseconds. How many milliseconds in a second? You're always dealing with milliseconds when you're in coding. So this wouldn't happen every second. Now in coding, we don't like to rewrite all our code. We're going to copy paste. So we copy and paste this, and we understand what this is because we've gone through the lessons, and we say, well, I don't want a soccer ball. Can't remember the other images we have. Maybe we have a spike. So we're going to say every second a new ball comes out. And if we hit refresh, here we go. Every second a new ball comes out. And we notice that it is going in the same direction, and this thing starts going crazy because you can't keep up. But at least there's more to look at in this game. This is the type of stuff we like our students to do. How do you make it two-player? How do you make a game over? We show them how to do a game over. How do you make the paddles move independent? So a simple game like Pong starts spawning these ideas, and we want them to go for it. Mess up the game. There's quizzes and tests where we can see how you're doing. You're going to upload your game so we can see it, give you feedback, but we don't want the same game every time. We want people to mess around with it. So here we have a ball. Now you know it was going in the same direction every time. We could push it in a different direction. We'd have to do some random numbers. That's where it gets fun with math. If you like math and you like abstract, logical math, it gets fun. Let's generate some crazy random number, and if it's greater than this value, then this happens. Otherwise, this happens. And so you can start to do fun events, and that's why I like coding, is the kids can get some instant gratification from what they write. That's why JavaScript's a great language, and they're going to get ideas that we want to feed and have them create. And I don't care what they're creating. It could be something, we get some strange stuff, but that's fine. We want their creative brain working because it all is going to boil down to logic and understanding how the computer works. Okay, this is usually the longest segment of my conversation or my presentation, and the kids like to see the score start going crazy with all the balls in there. But doing it online, I realized that this is a shorter section, and that's okay. Because you guys can hit us up on chat. I want you to be able to ask us any questions. Oh man, we're gonna hustle back to where we were. I guess it didn't save it, and I'm a coder. I'm not always know how to use all this technology. Okay, so here we go. We just tinkered, and that's gonna be a process when they're doing coding. It's so important. If let's say you're doing another company's coding, you already have a coding program, or they're on Khan Academy, they need to edit stuff. It's just so valuable. And I'm going to talk about what comes next after that. But first, what's a computer language? Some people say, I want to learn how to code, and then they're bombarded with questions. What do you want to learn? Java, C++, C, JavaScript, Python, Lua, Unity, all this stuff. There's a million of them. There are a lot of languages. JavaScript, Python, Java, HTML, CSS. That's what we teach. And there's a reason behind it. And that's not to say these other languages are bad, because they absolutely are not. But we have to work within a school system, and so we want something that we don't have to install, so we don't have to deal with the IT guy. JavaScript is awesome for that. You're up and running. Python is just a valuable language because it teaches you great habits, forces you, or else your code won't work. And then Java is what the AP computer science test would test them in. So if you have a student who wants to dive into coding and they maybe want to get some college credit out of it, it's going to ask them, that test is given in Java, written in Java. So you have to know Java in order to do the computer science test. So we teach JavaScript, Python, and Java. These other languages are fantastic. Now we also happen to choose very popular languages. JavaScript, so there is a company called GitHub where everybody uses it. In the lessons they're going to use GitHub. And people upload their code open source so that you can look at it. And this is based on GitHub repositories. So JavaScript is the most. And then Ruby, wonderful language. Oh, I thought I had another slide. I guess not. Because Java's, it doesn't matter. We're not going to go into that. Java's a great language. Tons of jobs for that. JavaScript, Google and Facebook have just taken hold of it and built so many cool frameworks. And then Python is making a comeback. Python is valuable because it forces great habits. Okay, so how do you start? Working with coders, and I have them build a system, right? So they build something for our company. This was before Simply Coding. And then we would revisit it and say, okay, we need to improve this. And they'd look back and they'd think, man, what was I doing? And you know, you don't get mad at them for that. They did what they knew, but now they've learned more. And they're like, I should have done this. Like, well, they didn't know that. So how do you start? You can't start with saying, I'm going to have the most efficient, the greatest, the best code. I'm going to be able to build a Pong game in 4 lines of code. It's going to be so sophisticated. That's not how we want them to start. Everyone looks back and says, what was I doing? That shows growth, it shows progress. A wise man once said, the secret of getting ahead is getting started. We want them to start. Let's learn, let's begin. Let's put your first ball on the screen, and then we're going to worry about what comes next. So begin with the end in mind. So I talked about tinkering and building their own games, and for what? We've talked about portfolios. So I want to show you our website, Simply Coding, and we have an area that highlights the kids. We do game design competitions. I need to do one again this fall. We usually do them after the summer when we have a lot of kids do our summer camps. But number one, when a student builds a game, we want them to send it to us. We're going to put it on our website. These are games written by kids, coded by kids. Some of them work completely. Some of them work halfway. That's okay. They've done a great job. As they give me updates, they send me the updates. So this is a section where we highlight kids' games. This student drew his own images. Proud of him. A lot of these kids end up drawing their own images. You know, these are fun games. This game was unbelievable. This was a girl who was in high school, I think a junior or senior. This is one of the best games, code-wise, I've ever seen turned in. Way to go, Allison. So we have these kid games. Now then, also we do these coding demos, but that's not what I wanted to get into. I wanted to show you, as you're going through our curriculum, and this is what our curriculum looks like, educators curriculum. As you're going through the curriculum, this is our coding pathway. So we have these beginner courses, meaning we assume you have never done coding in your life, and we're going to start there. But it is going to be real coding. So real quick, the difference between Simply Coding and some other great programs out there like Scratch, Code.org, even Khan Academy, is a lot of it is block coding, meaning you're dragging and dropping block. It's fantastic for the 6-year-old to 11-year-old group, maybe 12-year-old depending on the kid. It's awesome for that stuff. Teaches them logic without having to type it and make all the mistakes. We consider ourselves the next step, where you will have your text editor as you saw the code, and this will be looking like that when you open it. And you're going to write the game from the beginning, and you're going to, not everything's typed out. Some of it you can copy and paste, but you are going to have to type some of it out to learn it, and you're going to have to do the syntax. If that's gone, your code's broken, and we'll help you find it. And you'll probably be able to find it by looking at the lessons. So we start with JavaScript because it works so great in the browser. This is one of our most valuable courses, Intro to Website. The reason being is you're going to learn how to build a website. Woo. HTML and CSS, they're going to build their own website. Do this responsive website course. You're going to create a responsive website, meaning if you look at it on a computer or on a phone, it's going to adapt to that device. So we're now getting into some business stuff where this is coding techniques they use in the real business world. We use Bootstrap, if you know what that is. So we have this responsive website. Now the reason I love these website courses is because after you do them, your final project is to build a website to house everything you do. Meaning you're going to create a website. Then as you complete this JavaScript game design, you have somewhere to put and show what you've done. You're building a portfolio. As you complete Python, more JavaScript, these Java courses, virtual reality, 3D game design, Android apps, you go back and put it on your website and build this portfolio. If you like theater, if you like art, if you like, I don't know why I said theater, if you like video, art, maybe you like to draw, maybe you draw on the computer, filmmaking, you have a website to show all of your stuff, not just coding, but the other great things that kids do and the hobbies and skills they get into. Picture taking, photography, you have the know-how to build a portfolio and add your stuff to that website. So this is a simple version of a portfolio. We've had some very elaborate ones, but I just show the basic, simple version. that anybody can do. And this highlights their project. So these are the projects that we put together, this little student sample portfolio. They're taken from a couple different students, and we just made this collage here of stuff they've done. Oh yeah, here's our Minecraft mods course, and they YouTubed it and showed us how it works. So we have this little, oh, that's a long video. We're not into that. Let's see what this one does. This one's even kind of long. Oh, let's do this one. Sorry, I'm jumping around. My computer can't keep up. I'm filming, I'm going to the website. So they built this rocket launcher. It shoots a little grenade and blows up. So that was a mod they did. But if I were to click on any of these, they work. It's the actual game code. And if you're in an interview and they say, what have you done? You say, well, let me show you. Oh, I was about to actually show you. I was looking for something called view page source. Yes, there it is. You could open this up and say, well, here's what I've done. And this is the way that the game works. And this section right here is how you destroy the boss. And this is the logic behind it. And you can show this stuff in an interview no matter what your interview's for. And it shows commitment. It shows dedication. It shows creativity. There's a lot of great things that this shows. And now they're going into interview excited, comfortable. I get to talk about my portfolio. I get to show them the game that I built. And I get to explain it, just like my son explained to me about his redstone in Minecraft. They get to do that with a purpose in an interview, with this fun thing that they've created. So this portfolio is the highlight of what we do. This is every class hits on it. Every course that you do, we're talking about the portfolio. In those website courses, you're creating it. You're creating this shell. You may only have this on it to begin with, this website and the responsive website, but then you're going to have this browser game that you finish, and now you have more stuff to add. And like I said, if you're into videography, photography, put that stuff on there, because it's a portfolio about the student, and we just want to give them the tools to be able to do that. All this code is theirs. So that's our pathway. Oh, I ran out of breath there. We have other things that we do for students before we get into actual cost and price. Every Thursday, it doesn't happen every Thursday, but every week we try and post a YouTube video that shows some coding demo. So we've just taken fun games. Zelda 1, that was a 6-part series. This will load eventually. It loads a lot faster when I'm not recording. But this is how Zelda 1 was coded. Here's how Space Invaders, our interpretation. Here's how you'd code Space Invaders in JavaScript. And so we made this little video series where we're explaining the code. Here's Ski Free, that old fun game I played as a kid in the 90s that came with the computer. Here's Frogger. So just little fun projects. So kids send us ideas sometimes, or we just come up with our own, and we post YouTube videos so that they could just see code being used in other areas, again, along the lines of gaming. So, not necessarily gaming, but coding used in games. So we would love for you to try us out. We do a 14-day trial. We want you to just, there's no 14, well, I guess there kind of is. There's an ad drop in college, but so that's what this is. This is your ad drop period. You have 14 days. It does cost $1, where you can test drive this out. The chat support, everything's included. You get all the stuff here. So this is the coding that we talked about, the Step Beyond Tinker, scratchcode.org, Code Academy, because you actually get the environment on your computer. There is nothing hidden from you. You are writing the code, and everything is yours on your computer. So you'd learn how to build your own games, websites, and apps. You are making the coding portfolio. That is a major piece of what I want to communicate to you. Live mentor chat support. I'm in Central Time in the beautiful place of Pensacola, Florida. We have an office also in Salt Lake City. And we have a lot of workers that we hire during the summer to help us run summer camps. So we do chat support Monday through Friday. And, oh, my daughter walked in for a second. I'll go say hi to her in a minute. So we do chat support Monday through Friday. And if you're on our website, you probably saw it pop up in the corner. So we right now offer a $29 a month membership after the 14 days. But that's not all. We'll do a discount for you guys. So if you go to our website, there's the chat support I was talking about. You can click on that 14-day trial. Let's say you came in here to start your trial. So many steps in WordPress. Click sign up now. What I want to show you is we have our code that we're giving to all our homeschoolers called Code 10. Very creative name. You get $10 off. So instead of $29, it's now $19 a month. So you get 14-day trial, $19 a month. So if I hit apply code, what you'll see is it's $1 for the sign up, 14 days, and then it's going to be $19.95 a month. And that's just month to month, as long as it takes. This is 24-hour access. You can get on at any time, so some kids consume it quickly, some takes a little longer, so we just decided we're just going to do a monthly price. We used to have it, oh gosh, $2,500. We used to have it where you'd pay per course, and we still have some options there, but we have the monthly membership, so you can just go, and as they finish a course, the next one opens up. So what I wanted to show you is we do offer these courses in schools. For that reason, these are all a semester long, 0.5 credit. So there's about 40 hours worth of curriculum. If you were to watch every video, do all the lessons, there's about 40 hours worth of curriculum. And so these are 0.5 credit, and then they have the final project. So that's about what you could plan on. Our charter schools do 2 to 3 hours a week for 4 months. Now let me just log in. So you know everything. If you need to get off and go somewhere else digitally, feel free. But I just want to show you what the lessons look like. Now I'm logged in as an admin. I couldn't remember my user password, so this is the full control. I've never beautified this portal. Here's what stuff we like to make pretty. Hopefully it looks nice. Okay, so the Simply Coding pathway. Let's click on this JavaScript course, since I've kind of been talking about that. So once you click on your course, this is what you have. This is what our management system looks like. So if you were on, they would have lesson 1. They have to pass lesson 1 quiz to open up lesson 2. So if you're on lesson 1, this is what a typical lesson looks like. You have content. We're introducing a new topic. This topic is how do you get images on a screen? So we have this little example of 3 images in a screen. We show them the code. You can click on the code to kind of break it down, understand what's going on. Now you can either read through this, or you can click here and watch a video of it. You click this arrow. Now we're talking about displaying images. How do you get an image up on the screen? In a lot of these lessons, the middle one is going to be an activity. So most of these are 3 or 4 slides each per lesson. So this one's more of an activity. Okay, so the set size needs 2 numbers. The first number is the width, second number is the height. If I put a number in, made that pizza super small. So they can start playing with these, with some coding, with inputs, values. Then they can test it out in this editor. We can see how the code looks. Again, every one of these has a video, so they can either read the content or watch the video. And then on these testings and most of these middle slides, there's going to be some engagement where, oh gosh, wrong button, where they are going to be able to type in here and run their code. They're not in their project yet. They're just toying around with what they've learned. Okay, so how do you move this ball around? Yeah, so if they came in here, ball dot center, they're actually going to type this out, and they're going to start to see how coding works. It centered this top left pixel. That's funny. And then there's always an activity. The activity is step-by-steps with hints, them doing this project on their computer. They're now building it lesson by lesson, layer by layer, and they're going to have a fantastic game at the end. And we love doing it. Chat with us. We're going to be on, looks like I did a demo with Danny, who's the last time. So chat with us. We want to make sure they can come to us and feel supported. We want it to be a good experience. There is a learning curve. They will make mistakes. That's part of what we want too. I mean, that's life. That teaches some fantastic lessons. When you have to hunt for the missing bracket, you become more careful with your brackets. When you spell a word wrong and it doesn't work, you become more careful about spelling. So those are lessons that are taught by the experience of coding itself. So I hope you enjoyed this. Ask us questions. Let us know. Again, our discount code is code10 at checkout to get, everyone gets the 2-week trial, but you'll get it for $19.95 a month. And we do a lot of fun things. We like to be engaged with the kids. We want to help them build this portfolio. We will absolutely spend time helping them get this designed and created the way that they want, because this is going to be a reflection of them to the outside world. So thank you guys. I hope you enjoyed it. And let me know if you have any questions. We'd love for you to do the trial, see if it's any good. All right, we'll see you later. Bye.